Hello friends, welcome to Engineering Funda family. In this video, I'm going to explain you how exactly programmed IO functions. And that I'll explain you with one very interesting example. So that will give you idea about how many issues are there with programmed IO and how exactly programmed IO executes instructions. So let us try to understand that by one practical example. If you observe, here we are having a basic architecture of input-output organization with CPU. And here you see this IO devices that has been interfaced with CPU via system bus. You should know, my dear students, system bus, that is a combination of address bus, data bus and control signals. Right. Now here let me consider one practical example in which this CPU that is operating at clock frequency of 1 gigahertz. So as if it is functioning at operating frequency of 1 gigahertz, you can say clock cycle time period that will be 1 nanosecond, right? 1 divided by 1 giga, that will be 1 nanosecond. Nano means 10 to the power minus 9. Now here let us consider one program execution in which instructions are getting executed one by one with respect to this CPU. And let us say CPU is encountering one equation, that is LDA IO0. LDA means load direct accumulator from this port IO0. So accumulator, that will be the resistor of this CPU. So let us say we are having one resistor inside, that is accumulator, that we are dealing with to load from the port address which belongs to IO0. Now here we are having input output device. Let us say I am connecting keyboard over here. So probably speed of keyboard that will be there in terms of kbps. Let me consider 1 kbps speed over here. So as if 1 kbps speed is there, what will happen with this speed? How much time it will take to give data over here on this system bus? As per 1 kbps, 1 kilo, you can say it will take 1 divided by 1k means 1 millisecond, right? Milli means 10 to the power minus 3. So here, once this CPU is executing this instruction, it will be giving command over here over this system bus regarding loading of data from this IO port. But this IO port is slow. It will take 1 millisecond time to give that particular data to load it inside accumulator, right? As per LDA. So you just think about a case over here in which CPU frequency, that is 1 gigahertz. So in one clock cycle, it will take 1 nanosecond. But here, because of this IO device that is very slow, it takes 1 millisecond to give that data over here inside accumulator, right? So here CPU will have to wait for millions of clock cycle. Like you see, in 1 millisecond, probably there will be 1 million clock cycles. See, nano means 10 to the power minus 9. Milli means 10 to the power minus 3. So CPU is waiting for this much amount of time period. And in this much amount of time period, it will be encountering 10 to the power 6 number of clock cycles. So because of this IO device is very slow, CPU will stay idle, or you can say CPU will be waiting for the data to be given by this IO port. So this is the big issue which is happening over here with programmed IO. Even in programmed IO, there can be two categories: IO mapped IO and memory mapped IO. So for that, I'll be making separate video. Right now, just consider the case in which CPU is waiting for 1 million clock cycles. Practically, I can tell you, like, CPU will be executing instructions in 2-3 clock cycles only, right? But here CPU is waiting for 1 million clock cycles. So that is what the major issue which is there with programmed IO, right? So here, if you talk about disadvantages, then CPU will have to wait for more time because of CPU is blocked over here as this IO device that is slow to respond to the instructions of CPU, right? And in this type of IO configuration, you will be observing performance of CPU that is slow. Now, how to address this issue. So to resolve this issue, you should be going for interrupt driven IO, or you can have direct memory access. So both of those topics that I'm going to cover in next coming video. I hope it is clear to you. Still, if anything that you would like to share it with me, please note it down in comment box. I'll be happy to help you. Thank you so much for watching this video.